Assalamualaikum warahmatullahi wabarakatuh. We are from 2 BMMVS1 which is from group 1, and our group member is ANNISA AISHAH binti ROZIMAN, Muhammad FIKRI bin NAHAR, NURUL AFIFA binti AHMAD, MOHAMAD Nur Aiman bin ZAMZANI, and SITI Nur Asikin binti LATIB. We are going to present about BBL project. First of all, our company name is Megah Company. Megah Company was established in 2020. People around the world trust Megah brands and technologies. In February 2021, the company reported sales had reached 10 billion ringgit and an operating profit of 2 billion ringgit. Megah employs more than 50,000 people worldwide, more than 30% working outside of Malaysia. We have branches in towns like Putrajaya, Ipoh, and Aigoro. Megah Company is a leader in providing value-added construction service to our customers throughout the designing and construction process. Megah is thus one of the most trusted companies in Malaysia that handle various types of vast projects. We pledge to establish lasting relationships with our customers by exceeding their expectations and gaining their trust through exceptional performance by every member of the team. Our vision for our company is we will be the most valued business partner of all our customers. And the mission of the company is we provide life cycle power solutions to enhance our customer business while creating better technologies that benefit both the customer and the environment. This is our organization chart, which is the project leader is ANNISA AISHAH, IZANI AFIFA as casting and procurement engineer, AIMAN ZAMZANI as CAD and analysis engineer, Asikin LATIB as manufacturing and assembly engineer, and FIKRI NAHAR as rapid prototype engineer. And the time plan for our project is meeting for profile company we're doing on week 5, discussion for project background and job distribution. Week 6, design idea and process final selection is week 7, product development and evaluation and function of cost. Week 8, discussion on the product structural and possible improvement. On week 9 until week 12, conclusion of the product. Week 13 and week 14, final report writing, design review CAD modeling and presentation on week 14. For chapter 1, which is introduction and background theory, our project title is Enlil wind turbine, which is what is Enlil? Enlil is the first vertical smart wind turbine. It has been designed to both harvest the energy from the natural wind as well as those created by passing vehicle. Objective of the project is the main objective of this project is to gain power from wind and reduce the amount of electricity generated from fossil fuel, resulting in lower total air pollution and carbon dioxide emission. Scope of the project focus is this project is comprised of improving the overall design, performance of the wind turbine and making the best structure and ability of each component assembly. Problem statement. 1. Spinning turbine blade can threaten flying wildlife like birds and bats. Second, there are limited locations suitable for wind turbine. Third, the sight of sound of the spinning edges cause headache, nausea, and the other health problem. Next, team member job scope. ANNISA AISHAH binti ROZIMAN was planning a project, giving instruction to the team and make project. NURUL IZANI AFIFA managed the cost, schedule and quality. Muhammad Nur Aiman bin ZAMZANI design, project and modify existing product. Siti Nur Asikin binti LATIB design and operation of integrated system of high quality. And lastly, Muhammad FIKRI bin NAHAR design, prototype and building up the physical product. Explanation of the device. Wind turbine operate on a straightforward premise. Wind turbine rated or utilizing power to create wind like a fan utilizes wind to create electricity. The propeller like blade of a turbine are turned by a wind around a rotor which spins a generator which generates power. Annealing wind turbines are designed to gather energy from both natural wind and wind generated by passing automobile. The aerodynamic force of the rotor blade, which are omnidirectional, convert wind energy into electricity in a wind turbine. They don't need to be angled into the wind to work. The rotor is connected to the generator via shaft and a set of gears, which speed up the rotation and allow the generator to be physically smaller. The conversion of aerodynamic force to generator rotation generates power. Enlil is a vertical turbine that uses dynamics of modern city to harness one of the most important renewable energy sources, wind power. It is meant to capture the quick and continuous flow of all traffic on a roadway in addition to the popularly recognized turbine. There are three major features that might lower wind energy costs of the Enlil wind turbine. A lower center of gravity for the wind turbine means decreased gravity strain stress and enhanced floating stability. Machine complexity is reduced and scalability to very large size is improved. Furthermore, the powertrain of an Enlil wind turbine is located at or near the surface, making maintenance easier and faster. Maintenance expenses are lowered because of fewer components, lower fatigue loads, and easier maintenance.
Assalamualaikum, my name is ANNISA Aisyah binti ROZIMAN, metric number B0920101443. I am in charge of chapter 2, which is designing each components of our product. The software that I use to design these components is SolidWorks. And from the slide, you will see all of the components that we use in our product. So now I will describe about our product component as well as its function. So the first component was base. Bases were made to support all of the components of our wind turbine. All of the main components of the turbine will be located at the base. Next is magnet. Magnet is made to improve reliability and reduce the need for expensive and ongoing maintenance. Magnet will also eliminate mechanical vibration as well as reducing noises. The third component is rotor blades. Its function is to provide lifts as the blades rotate. It will absorb the kinetic power of the wind and convert the energy to rotary motion around a central hub. Next is generator that will convert mechanical energy to electricity. The generator were housed at the top of a tower just behind the turbine rotor hub. The fifth component is bearing. Bearing is made to support shaft loads, reduce friction with rolling elements. Apart from bearing, We also made bearing bracket, which to support the weight of the rotor. It also allows the turbine to spin freely and transmit torque to the generator. Then, we also have this, which is to determine the optimum performance in the absence of blade drag. The last component is shaft. Shaft is the section that is rotated by the turbine blades. The shaft then linked to the generator located at the main housing. That's all for my part. I will pass it to the next presenter, Siti Asikin.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Asikin binti LATIB. My matrix number is B0920101005. Okay, as you can see here is the flowchart of our design. Okay, first we sketch down the rough design before we start sketching the drawing using the SolidWorks. Okay, after that we design the part model that we include in our product design. Okay, we make an assumption and prediction whether the parts that we chose is appropriate or not. If it is, then we proceed. If not, we create a new one until it becomes acceptable for our design. And next, after we done the 3D sketching of all our parts, okay, we do the drawing for each part before we assemble them. Okay, and when the assembly model made successful, we proceed to do drawing of the assembly design. And finally, we do the analysis of the module. And next is about technical drawing and dimension for each part. Okay, as you can see on the slide, there's the technical drawing for each part of the wind turbine. Okay, as you can see, like base, magnet, blade, generator, bearing bracket, disc and shaft. Okay, each of the drawing had been included in the dimension and the material of each part. Okay, you can see that on the report. And next is the drawing for the assembly. Okay, with material selection and bill of material. Okay, on the slide you can see I already put the number for each of the part. Okay, number one we got base and the material is the plain carbon steel. And for the bearing we set it as chrome stainless steel. And then for blade is ABS plastic. Okay, for magnet we use nickel. And for the generator we use copper. And for the three other part is this shaft and bearing bracket we use the same material which is cast stainless steel. Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Asikin binti LATIB.
Assalamualaikum and hi. My name is Mohamad Nur Aiman bin ZAMZANI. My matrix number is B0920101061. Now, I will describe the cost of product. The whole cost of producing the product is RM7,140 as indicated in the diagram. This is the table of the value cost per part item that we are required.
Assalamualaikum and hi. My name is Muhammad FIKRI bin NAHAR. My matrix number is B0920101044. And I'm going to discuss about the structural analysis result. After doing the simulation in the SolidWorks, one of the structural analysis that we got is von Mises. The maximum von Mises value is 1.74 times 10 to the power of 6 Newton over meter squared. And the maximum von Mises value can be found at the center of the top and the bottom disc. This indicates that the middle part of each disc experiencing higher level of stress than other parts due to the torque applied, which caused by the wind force. The second structural analysis that we did is the displacement. The displacement can be shown by the colored region when simulating the assembly part. The red region indicates the maximum displacement value of 0.001294 mm from the initial state which is experienced by the parts. As shown by the simulation, the prototype survived the 40 Newton of air. For the third part of the structural analysis, we look into the deformation. As shown by the video, the parts that are the most deformed are the top and the bottom discs, which hold the blades. This is due to the torque that is applied when the blades are pushed by the kinetic energy of the wind. With the constant airflow and the help of bearings, causes the wind turbine to keep spinning while applying torque on the structure. After we done on structural analysis, we calculated the factor of safety. The part that sustains the most stress is the disc. So we find the yield stress of the disc, which is 240 megapascal. By using the formula factor of safety equals to yield stress over max von Mises stress, we calculated and got the factor of safety, which is 137.93. In conclusion, the material will not fail even after applying the wind force of 40 Newton.
Next, I will proceed to techniques to improve design failure during analysis. The first one is fixtures on most bottom discs. Second, using the predefined material. And the last one is apply force only to the necessary part. Next, I will discuss about idea to improve the device. The project of Enlil wind turbine that was completed contains flaws and weakness of its own. As a result, various suggestions for improving this project have been made. So, the first one idea to improve the device is thicken the disc. The density of a disc increases as it becomes thicker. So, the disc has a stronger resistance to torque. As a result, more torque can be accommodated. Next, you should utilize a material with a high elastic modulus. When a material has a higher percentage of elastic modulus, it has a lower chance of deforming. Lastly, make use of variable speed transmission. Depending on the wind speed, this variable speed transmission will adjust the gear ratio from high to low or low to high. It can improve the turbine's efficiency, allowing it to keep spinning and generating energy continuously.
In conclusion, the Enlil wind turbine is a massive advantage for authorities. For example, Sri Lanka has a lot of problems soon due to the lack of non-renewable energy sources. Therefore, they are moving for renewable energy sources like wind, solar, rain, and sea wave. So, they can implement the Enlil wind turbine in every possible place and generate electricity while contributing to the reduction of CO2 production and economic growth. Therefore, this project is a green energy source that does not affect the Earth's life. Finally, we are pleased to say that the objective of this project has been achieved. That's all from our group. Thank you.